The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, good morning, wherever you are in the country. It's Mark from SolidCAM. We'll be doing our 30-minute free training today for SolidCAM Live. With me, as always, Kevin Rankel. Hey, Kevin.
How's it going?
So today, I thought I would continue with the theme of this week on how you can add geometry to help you with your toolpath. And today we'll be doing two toolpaths that kind of don't get used a lot, only because of what you have to do to get them to work, like we're going to see today. But some of them can be very useful if you have no other options. So a good example is the one we have on screen right now. This is a part. It's a version of a part from a customer that needed to take a T-slot cutter or keyway cutter. Let me just show you the tool. So one of these guys, and he needed to do that slot in there. And as you can see, there's not much room to move around. There's not much of an envelope there for you to work in. So you can't really just go and do a T-slot operation. I can't enter through here, through the top, because as you can see from those circles, the tool just has too large of a diameter. So solution was, first we mill all that out, obviously, as much as you can with whatever toolpath you have, Pocket, 3D machining. And then you cut yourself this slot so that the tool can come in, go down, machine that, and come back out the same way. Now, those sort of movements are not covered by Pocket, Profile, T-slot. Those would be what I would use if I had free access to this, but I need to control the movement of the tool to a T, to an exact movement, or else I'm going to collide with some of the side walls and the top and stuff. So what I did was I showed them Contour 3D. And we've seen Contour 3D in these SolidCAM Live. You've seen them in KevCam. But to me, this is one of the more useful applications of Contour 3D. If I show you the sketch that I'm using, it's basically this guy right here. That represents the center of the tool. So that large diameter tool has to go through that slot, dip down to that level, and then go around and mill both slots. There's not a lot of room to move, as you can see. If that represents the center of the tool, there's not much movement going on there. I'm just going in, coming out. So the way I did that was, again, kind of the theme of this week, sketching. I started with a sketch on this plane here, and then I added, you actually see there's two lines there. On this plane with maybe just a level up a little bit, I think I put a plane of, let's see if I have it on here. So with the plane, I'll just kind of recreate it real quick. I clicked on this plane here, and then I added 10 thou. So I actually made a plane that's parallel to this by 10 thou and 15 thou. There's not a lot of room in this slot to bring the T-slot in, so I actually just made it have a clearance of 10 thou from this face. And again, I'm controlling it by the center of the tool. So if that sketch is on that plane, that means the bottom of the tool is 10 thou above this face. And on the way out, it's 15 thou above that face. So the reason I had to do those two lines is because when you choose a contour for your Contour 3D, it has to be in that one continuous motion. I can't just overlap on the same line, because it gives me the error of you've already selected that entity, that chain. So I needed two lines to represent the exit. So I just separated them by 5 thou in the same direction. So that's what those two lines are, and they're made on a plane that's 10 thou and 15 thou parallel to that one. Then on the bottom, again, controlling the bottom of the tool and the center of the tool, I created these chains here, this one and this one, that were offset from those edges there. This is pretty much on size with the radius of the tool. So this line and this line right here are basically the tool just goes in, comes out, and that's it. I added this little line right here to link them. So let me just show you this whole guy again. So on both sides, there's a bit of a T-slot or a little groove kind of thing. The tool goes in, jumps across, and then does both. So those three lines on that plane, let it do that. And then I had to think about how we're going to exit. And that's what all of these guys are for. So let me just get that cross section again here. You can see that those lines are actually not planar. Those are sort of 3D. And again, they kind of overlap. So one from the entry, one from the exit, literally just a 3D sketch to these lines here that were on that original plane. So that's basically just, I'm telling it to go from that entry down and then from there, do a little bit of a lead in. So that's my lead in into the pocket. And all those chains together generate something that looks like this. So the tool comes down, feeds into that first position there. So there's my first entry. Okay, and if we take a look at this from this view right here, so it came in through that slot. And I know to stop it right there because, again, in the sketching, I would have drawn a representation of the diameter of the tool. I drew an actual circle, so I know I'm not colliding with anything. Now, again, this is a very basic version of the customer's part, but there's other features in there that have to be milled out. So I needed to avoid those, avoided colliding with those. So again, I made a bunch of sketches that represent those edges. But all of this goes down to the idea that I just drew some sketching to draw this exact trajectory of the tool. And then when I come into the tool path, I just select it. And we'll go through the specifics of the parameters. I just wanted to finish showing you this. So it comes in, goes down. And if we look at this from the side view, let me hide the tool. Goes in, into the part, exits the part to the next side, goes across, comes out. Let me bring that tool back in, get that view once again. And then from there, back up, and back out. And all of that was controlling the center of the tool. So all of that sketching, all of that consideration, checking for edges and all that kind of stuff. And then when I get into the tool path, I just choose the chain. That's it. I just told it to go across like that, following that chain like you normally do with Profile Pocket. I just gave it a direction, chose my tool. My levels, because this is Contour 3D, my levels are really just the travel of the tool. So that's as high as it goes and as low as it goes. I kept a contour depth of 0 because that's incremental to the chain that I chose. So I'm following that line exactly. And in technology, I told it the reference is the center of the tool. If you remember when we covered this last time with a ball mill or something like that, Kevin made a distinction of the tip and the tool center. Well, in this case, the tool center is the flat bottom of this tool, which allows me to tell it exactly where I want it to go. If it follows the bottom center of that tool along this chain, it'll do exactly what I want it to do. So the drawback is I have to tell it tool side, so I don't get anything like a proper lead in, lead out. I don't get the ability to give it any kind of clear offset. I don't even really have to choose anything like rough or finish. This tool path, these parameters are set specifically just to follow that exact chain. So in this instance, it's exactly what I needed to do. So it's kind of a unique application of this one toolpath, but oftentimes, especially with a part like this is the only thing you have to work with. You could not really pull this off with Pocket or Profile, a unique lead in, lead out. Sometimes you can pull that off with some of these toolpaths, but in this case, because we're going from one plane to the other, I needed to come in at a certain angle, or at least at a certain level, and then lower down. And the reason I didn't go straight down is because in the customer's part, like I said, there's a bunch of features here that I had to go around. So there's a lot of internal workings that when you do the sketching and you look at your part, you can figure out trajectory. But it goes back to what I was talking about. You can actually add a bunch of geometries, some sketching and whatnot that can really help you in your programming, because when I came here, I literally just chose the chain and that was it. I didn't have to do any extra programming. Everything was done on the sketch side of things, the geometry side of things.
And this kind of goes back to the point where when Mark was showing you guys how to do the manual turning, you basically just draw the lines in there and the tool will follow that line. So this is pretty much creating your own custom machining pattern right here just by that sketch line. So it really, if you guys are looking for something specific and you want it to follow a specific pattern, and we've seen this done, like if this guy had to do multiple step down or step, I guess, overs in X, what we could do is just take that sketch then and then copy it over to make multiples of there. So think of the Contour 3D is kind of, you want the tool path to follow that exact line.
That's actually a good callback to the manual turning, because this is the milling version of that, whereas the manual turning is the same thing, just for turning. So any questions on that from anybody that's seen this before, or if this is the first time seeing this toolpath used like this? It could be really useful, and it wasn't even really that hard to do because I'm just looking at the center of the tool. I actually worked on this a lot, trying to keep it on the right side or the left side of the tool so that you can use cutter comp. But I just couldn't figure it out, how to stay on one side of the chain. So when I set it up as the center, it made it very easy because all it is just offsets. If anything, this line right here is actually an offset from this side because, as you can see, there's a little bit of a curvature here. And when I tried to go down the center here, it actually gouged there. And I wouldn't have known that unless I did the solid verify. So this is kind of a combo of geometry, solid verify, and then once I figured out how I wanted to do it, it was just sketching it, and then I was done. So good example of how you can use Contour 3D to really just control your toolpath, almost like 100%. There's nothing here that the software is doing on your behalf. You have to tell it exactly where you want the tool to go. Okay, so if there's no questions on that, then the other thing I wanted to cover is we're going to go back to this part that we covered probably last week, the chamfer step down. And because I wanted to take a look at how you can do the translated surface on this. Now, translated surface is kind of like a bad word, that's all I can, because we hate this toolpath. But it is not that hard to work with if you can get it if you can figure out how you use it. I'm going to do that now for us, and you can kind of see my success there, but I'm going to.
And we'll start off as you guys have two different options to do this oversized chamfer. You got the easy way and you got the hard way. The easy way requires you guys to buy HSS. The hard way is included with what everyone has already.
Pretty much, yeah. When we talked about translated surface the last time in SolidCAM Live, we basically we give it a bad name only because it's hard to work with. You got to know how to use it. But once you know how to use it, it could probably be your best friend if you only have the 2.5D package. So like Kevin said, if you're looking at doing some of the stuff that translated surface is able to do, you're probably looking at just getting updated to HSS anyway, because you'll get a lot more functionality. It's a lot easier to use. But let's say you have this and you got to get going. So we've got what basically is a cross section, this line right here, and a path. That's basically all translated surface is looking for. So if you have this consistent cross section across the path, even if it's just these straight lines, then you've got what you need for your translated surface. So calling back to translated surface, but also staying with the theme of this week of geometry can help you, I need to program that. So I'm going to go back into my part, right click on design model, edit the part, and now I'm going to sketch. Now, if you remember from when we talked about translated surface, or if you've seen the training video on translated surface, the cross section has to be on the same plane as the path. So we're actually going to recreate the cross section. And since this is just a straight line, I'm just going to draw a straight line. But what you could have done is actually open a sketch on this face, did a convert entities to grab the edge of your unique looking profile, and then just copy and paste it to a sketch on this plane. So let's go and let's just add a sketch on that plane. Now, what makes translated surface difficult in a certain way is it's not just the sketching. The sketching can be easy because you know you want a path, you know you want to have your cross section, but where you put your cross section is the painful part, because it needs to actually be in the lower quadrant. It's kind of odd to describe it, but if you look at your XY plane, if this is my reference point, which is what I'm going to choose as my reference point, I need it to be over here. That's really the way I understand it. Just if you take a look at if the XY origin was here, this is the X-axis, and then this is the Y-axis, I need it to be in this lower right quadrant. That's the best way I think of it, and the best way to describe it. So if our cross section is just a line, I'll just draw a line from there, like that. And I've already measured it, but I know if I didn't know, I could just click on this line and say, okay, that is 0.71 inches in length. So I'll make this one 0.71 in length. Okay, and then we need to put an angle on there. And again, I know what angle it's at. It's at 45. So I'm just going to make this a 45-degree angle. Okay, so now I have a sketch that represents my cross section. It looks a little odd in terms of the placement, but that again is because it has to be in that lower quadrant. Now let's go and actually use that chain, that new geometry that we've added to help us out here, to do our translated surface. So translated surface, the geometry is the path, which is this straight line right here. And then as soon as I choose that, it asks me for my section geometry name. So I'll click New. I need to choose my reference point, which is that point right there. And my recommendation is usually to have the reference point as that end of that chain, but also have that coincide with where you want it to fall on the path. You can probably do some sort of offsets and that sort of thing, get some sort of step down. But again, this toolpath is hard enough as it is. Just line those up in the same point, and then you'll conceptually be able to figure out what you're doing. So I'll grab that point there. And then the chain, I'll just click add, and I'll just grab the chain going in that direction. So again, it kind of doesn't make sense when you look at the path and that, but again, lower left corner, lower right quadrant of the toolpath. And then I believe I needed to put this on the right side, because in this path, I need it to be on the right side. Let's just choose a tool. So I'll go with my 1-inch roughing tool, levels. I'll just click on the top of there. So that's the top of the toolpath, but that's also going to relate to that reference point. So that can kind of give you some depth to work with. You'll see this with, I think it's the slotting toolpath as well, the distance that the chain is away. Again, to avoid confusion with this toolpath, just make sure everything lines up, and then you can have your upper level as just whatever plane those sketches are on. Technology, very bare bones, because again, what we're doing here is just very simple. We're just following a path. So I'm going to set it up as having a roughing of, let's say, step down of, we'll just put it in as 50 thou, so we can actually see lots of steps, and then overlap. If I highlight that, bottom left corner shows us that that is overlapping with the previous pass. So I want this number to be something a little larger so we can actually see a couple of passes. So I'm going to overlap by 80%. So I'm really only stepping over by 20% of the tool diameter. Okay, and we'll just leave these finishing passes here. And if I put in the scallop height, you can see that it'll try and calculate a scallop based off the tool that I added. Now for our flat end mill, it's probably not the best use for this, but if I were to put a ball end in here, I could probably get the same sort of thing I would get with an HSS linear. So kind of going back to HSS is probably the better way to do this, but we'll use this for now. So save and calculate. Let's take those lead in, lead outs, maybe just make them normal. Okay, so there you go. So you got a couple of roughing passes, and then you've got those finishing passes. And to distinguish them, I'm just going to turn off one at a time. So there's our roughing. Do a save and copy. And then we'll just do the finishing this time. And if we take a look at that in our solid verify, let me just get rid of these guys. Rough, finish. Okay, and that's all with the addition of that one chain there. Make sense?
Makes sense. Well, to me at least. Now, one other way, what we could show here, Mark, is another situation on something like this, where let's show in the profile operation as the, I'm trying to think of it, go ahead and open up our profile operation. And go to the technology and advanced, the wall draft. That's what I was thinking. So,
yep, so this was what we covered, I think the last time we looked at this part.
Okay.
Yeah, but we can review it here if we want to just do a simple roughing. So let's go geometry. For simplicity, I'm just going to go on this side, grab that. And what the wall draft angle allows us to do, let me just grab a tool. We'll use that same tool, tool 57, is instead of just going down, let's say from that plane to this vertex here, in just our constant step down of, just put in 0.1, instead of just going straight down, which we would normally do with a profile, now gives us the ability to add a wall draft angle, basically giving it an angle. So instead of just going straight down like that, we're going to go down at an angle. So we'll go wall draft angle. Wall angle is 45. And it looks like either I got this right or I should have chose the bottom chain. Let's see. Nope, okay, so that line represents the center of the tool. So if we take a look at this from this plane, the tool center line is following that chain there. You can see it's in contact, and if we go through this whole thing, it's doing a profile at that angle. So this is another way if you have a very simple geometry like this, basically just a wall drift angle to your profile, then you can get this done as well. And this would be, if you didn't have HSS, this would be the way I would do this one, especially if it's just that simple 45-degree angle. If it has any kind of weird profile to it, then that's a translated surface. But if it's just literally just this one line, then I wouldn't bother sketching. I wouldn't bother even looking at translated surface. I would come right here. And if you're asking if it can work on anything other than that straight line, well, when you go here, that's what this whole thing here is for. If you look in the graphic in the bottom left corner, you can tell it how you'd like it to address those corner changes. Either you can just get it to be a simple continuous radius, you can do a conical fillet, or you can just be sharp. Is that what you're looking for, Kevin?
Yep, absolutely.
Okay.
Any questions, guys, on this one? And I promise if Mark brings up translated surfaces again, we'll hurt him. No, I'm kidding.
Yeah, I was curious what we would do with a clear offset. So now this is just me freestyling it for the next couple of minutes here. Let's go with a really something like this.
And that's just going to do the last final pass. It won't actually do the clear offset for the 45.
Okay. In that case, then this is another opportunity for Contour 3D. If you actually drew in all those lines, and then you can just select them in the order you'd like this thing to go, then you can actually get that that profile. Or you chose a series of profiles and you just set your levels to 0, then that can follow that as well.
Now, what I'm going to do is I'm going to call out Scott, because I see Scott's on here, and he's in here often too, which we love to see. Scott, right now, as it sits inside SolidCAM, what is the one thing that you don't know or you would like to know more about inside the software? On your day-to-day programming, what is one thing that maybe gives you troubles or that you would like to know more on? And you don't get to leave this webinar
know more
until,
about, yeah, not
yeah.
more on.
Yeah, more on. my Minnesota accent is getting in the way there.
No, I mean, what? You're not calling him a moron. You're
No.
asking if you'd like to know more about something.
Yep.
So yeah, Kevin called out Scott because I think you've had some recent text board discussions with him. But anyone also could ask any kind of question they've had day to day with this. I mean, that's the point of SolidCAM Live. And like we end with every day, we always say if you have any questions or anything like that, feel free to send it to us using either of our emails. You have Kevin's email because of the KevCam videos that get posted, but you've also got my email from when we posted at the end of these sessions. So anyone that has any questions at all about day-to-day, anything that's giving you trouble, I go on Facebook, on the Facebook pages a lot too, just to see what questions people come up with. And any of that stuff becomes either a tips and trick video, becomes part of the SolidCAM Live, or goes and gets fit into the topic that gets covered in KevCam. So definitely anything that you guys would like to know, that's our job to get you guys to know what that is. If you've got anything now, go ahead and put it in the questions panel. We're pretty much out of time for today, but if you put it in the questions panel, we record that, we add it to the things of the list of topics we'll be covering. But Kevin's going to put my email in the chat section. Looks like it's already there. And basically, you can use that email to send us your topics, your questions, your comments, anything you'd like covered, anything you'd like to see, anything you want us to review. Because remember, this is SolidCAM Live, so if we need to go over a topic again, we can do that as well. if you want your own personalized training, like you saw, the previous part we talked about today actually came from a training session with a customer who needed to know how to do that. And rather than try and just write it out in an email, we did it live in a training session. I showed them how to do that live, adding sketches and that sort of thing. So if you want your own personalized training, you can use that email. If you know anybody that can benefit from SolidCAM, give them our contact info, get them to call us. Either way, if they get into a demo, you get that $100 gift card. If they go to sale, if they buy SolidCAM, then you get that 20% of that sale. So you can get some money just for letting us know someone that's interested in SolidCAM or InventorCAM or any of the other products that we sell. We'll be continuing this every day at 2 p.m. Eastern time. For now, I know I keep saying the end of the month, but I have a feeling it's going to be a little longer than that. So if you guys like what you see, let us know, and we can continue this past the end of the month. But like I said, we'll be doing this every day, 2 p.m. Eastern time. Until then, stay safe, keep your family safe, stay busy. We'll talk to you guys tomorrow.
All right. Have a good day, everyone.